Hey guys, here we are with Module 5, Lesson 2. I keep wanting to say Module 3, but it's Module 5, Lesson 2. We are continuing with the fractions. Our objective for this lesson is I will be able to decompose fractions as a sum of unit fractions using tape diagrams. So very similar to what we did yesterday. Probably the only difference today is that we are going to decompose it different ways and understand that there's, if we have 5/8 like this first example that we have, there's multiple different ways that we can decompose and show that 5/8. Okay, so if we look here, we have 1A and there's different steps that it's asking us to do. So it says draw and shade a tape diagram of the given fraction. So they gave us 5/8. So they broke it into 1, 2, 3, 4, 5, 6, 7, 8. Remember, if our denominator is a certain number, that's how many pieces we have. Our numerator is how many pieces are shaded. Okay, so if we have 5, there's 1, 2, 3, 4, 5 pieces shaded. It says record the decomposition as a sum of unit fractions. So we have 5/8. They showed each of those individually. So 1/8 plus 1/8 plus 1/8 plus 1/8 plus 1/8 equals 5/8. But you could also do 2/8 plus 2/8 plus 1 because 2 plus 2 plus 1 is 5. Or you could have done 2 plus 1 plus 1 plus 1, 2, 3, 4, 5. So that's kind of our focus today is showing a fraction in a tape diagram and showing that we can decompose it more than one way, okay? All right, so we have 9/10. So we are going to insert a table. No, I don't want the letters on it though. Hang on. Insert a table that has 10 units because that is our denominator. And we're going to show 9/10. So 9/10 of this is going to be shaded. So we need to shade 9 of these, 9 of our units. Okay, so we have our 9/10, which is showed in our tape diagram. So now we need to show that 9/10 is equal to 1/10 plus 1/10. How many do we have? 9. So we need to show each of those. 1/10, 1/10, 1/10. Let's see, we've got 1, 2, 3, 4, 5, 6, 7, 8, 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. And they should look like these ones up here. I'm not sure why it's not converting over to fractions, but you get the idea. So 9/10 is equal to 1, 2, 3, 4, 5, 6, 7, 8, 9/10. So it wants us to show it that 2 more ways. So we could say that 9/10 is equal to 4/10 plus 5/10. Because 4 plus 5 gives us that 9. We could also say that 9/10 is equal to 2/10 plus 5/10. That gives us 7 plus 2/10. The larger the amount that you have, the more different ways you can decompose. So 2 plus 5 is 7, plus 2 more gives us that 9. So we have 9/10, and we showed it in our tape diagram. All right, we're going to do another one. 3/2. So this one is a good one for us. I'm glad that they gave us one of these. So what do you notice about our numerator and denominator? I notice that my denominator is 2 and my numerator is 3. So what that means, okay, when we're talking fraction talk, if our numerator is larger than our denominator, that means I have more than one whole. Okay, so what this is going to look like, I'm going to need 2 tape diagrams. And I'm working with halves. So I'm going to have one that's equal to, and then my next one, it did this to me last time. There we go. All right, so here's my one whole broken into halves, and here's another whole broken into halves. And I have 3 of those, okay? So 3 of these are going to be shaded. So anytime your numerator is larger than your denominator, you have more than one, okay? So I have 3 halves. I could rewrite this as 1 whole and 1 half, okay? So this is a fraction, this is a mixed number. We'll get more into that later. But if I have 1, and you can see that really well, that 1 1/2, I have 1 1/2, 3 halves, okay? So how can we decompose this? Well, we could say 3 halves is equal to 1 half plus 1 half plus 1 half, right? Because I have 3 halves. We can say 3 halves is equal to 2 halves plus 1 half. And then we could say, see with the smaller amount, there's not really, we could flip that and say 3 halves is equal to, I keep putting plus, is equal to 1 half plus 2 halves, or we could have went like this. 0 halves plus 3 halves. We did a little bit different than what we did earlier. Okay, so numerator, top number. When it's bigger than the bottom, your denominator, you have more than one whole. So here's something that I want you to practice too. So if I were to say how many halves does it make to, how many halves do I need to make one whole? Well, halves is 2, right? So I need 2. It's always kind of taken as a trick question. How many tenths do I need to make one whole? 10. How many eighths do I need to make one whole? 8. And when I look at this, if I had all of those shaded, I'm broken into eighths, then I would have one whole. Same with my tenths. If I filled in all of these tenths, I would have one whole. So I'll ask kids that all the time, well, how many eighths do you need to make a whole? Well, your answer's in the question. I need 8 eighths. I need 10 tenths. I need 4 fourths to make a whole. No matter what it is, whatever you broke it into, that's how many you need to make one whole. So if you have more than that, you have more than one whole. Okay. We can do, we'll do one more, and I'm going to save the rest of these for your practice. Okay. So I have 7 eighths. So I'm going to draw my tape diagram. How many units am I going to have to break that into? 8, right? That's my denominator. So I'm going to have 8. And how many of those are going to be shaded? That's my numerator. So I have 7 eighths. So I need to show 7 eighths. How many eighths do I need to make a whole? 8. Hopefully you said 8. All right. So there's my 1, 2, 3, 4, 5, 6, 7 eighths showed as in a tape diagram. So 7 eighths, we can write this as is equal to 1/8 plus 1/8 plus 1/8 plus 1/8 plus 1/8. When do we got, guys? 1/8, that's 1, 2, 3, 4, 5, 6 plus 1, 8, 7, and 8. Or wait, I do one more. 1, 2, 3, 4, 5, 6, 7. Oh, yep. Okay, how else can we show that? We can show 7 eighths is equal to, what if we did 4 eighths plus 3? Well, that's how I get it right as a fraction. Okay. 7 eighths is equal to 4 plus 3. 4 plus 3 we know is 7, so that would be 7 eighths. We could also do 7 eighths is equal to 5 eighths. How many more would I need to make 7? 5 plus 2 gives us 7. Good. All right, so I'm going to save the other ones for your practice questions. Look at this next one down here. Okay, 5/3. That means I'm going to have more than one whole, right? So we need 2 tape diagrams to represent that. Both my diagrams will be broken into thirds, and I would shade in 5 of those thirds. 5/3. All right. This one I'm going to keep for your practice. You'll get to do that one. All right, you guys, good job today. Keep working hard. Fractions are fun, and you will master it soon. We'll see you guys soon. Bye-bye.